Hey there. Okay, here we got the SchmittTrigger circuit, part 6.3 of lab 7. We've got the 311 comparator. Okay, and let me show you what we have on this setup. I'll show you where the rails are, and then you can trace everything else out on your relative to figure 6E of the lab. We've got the 15-volt rail up here. Down here at the bottom, we have the minus 15-volt rail going horizontally, and right above it is the ground rail, also going horizontally. So that way, you keep going down in voltage from high to low, so you don't get confused as to which rail is which. Over here is the pull-up resistor. Here are the two SchmittTrigger resistors, and between them and the divider, they're going back to pin 2, which is the reference voltage terminal of the comparator. You see the output over here, which is going to our friend, the scope probe. Yes, indeedy. So let's now take a look at what we see on the scope. I've got a 1 kilohertz sine wave coming in from the function generator here. And let's see what it looks like. Okay, looks pretty good. Right on the screen there. And the lower signal there is the input from the function generator, and the upper signal is the output from the comparator taking off the bottom of the 4.7K resistor. Now let's expand this a little bit. Okay, let's look at the edges of the square wave, and I want you to notice the sine wave, when it crosses 0, is when the square wave changes, which is what we expect. Okay, the reference voltage is going to be 0 at this point. So I'm just expanding the horizontal scale right here. Okay, so I've got my nice SchmittTrigger here, and this transition looks pretty clean. It's got some slewing issues when you get right down to it, but we have a kilohertz frequency on this, so and I'm at a 1 microsecond time base, so that's pretty good. You can't really see it on the millisecond time scale. Now let me instead, I'm going to remove the SchmittTrigger, and I'm going to ground the reference input instead, and look what happens. Okay, this is what you did in part 6.2 of the lab. Those are your oscillations, and that's where the output can't decide whether to go up or down, because the input, which is here, very low slope from the sine wave, is right around 0. Okay, and now I'm going to reconnect the SchmittTrigger, and voila, as you see, those oscillations go away. So this is what the SchmittTrigger does for you. Even though you wouldn't see it on the millisecond time scale. Okay, let me go to a millisecond. You really can't tell there's anything in there, but I start expanding out, and you start seeing that fuzz, and those are your oscillations. These are not LRC circuit oscillations with inductance and capacitance. These are the output actually flipping back and forth for a number of times until it finally decides that the input sine wave is safely above 0. So, no positive feedback, SchmittTrigger feedback. There you go, and that's what you should be seeing on your scope. Good luck.